Hello, I am Noah Monk, he, him. I'm a fourth year honors physics and philosophy student, and this is my research on the Eddington capture sphere. Motivated by some of the past ideas that we've known that light can actually interact with gravity, fundamental principle used in light sails, sailing on light, we decided to examine results around compact objects like stars and see how they interact with strong gravitational fields. More specifically, the case is when the radiation leaving a star is so strong that it actually counteracts and balances the force of gravity entirely. So in such objects, you can actually have a bunch of matter like particles flying around, and they will actually settle upon this sort of Eddington capture sphere or surface, where radiation and gravity are perfectly balanced, and they would just sit on the surface. The thing that makes our research more unique is the past work on this only considered constant surface brightness. We generalize to any kind of surface brightness, any temperature distribution on the surface, which gives us many different kinds of shapes that we can form, like these ones, which aren't completely spherical. This is more of an example of a spherical one, although it's only looking at 2 dimensions, but this one's there to demonstrate all of the various complex particle paths as the radiation and gravity work against each other to form these paths. These ones are figures of after the particles have all settled down onto the rings or the surfaces, the Eddington capture surfaces. These are the different shapes for various different temperature distribution on the surfaces. Our future goals with this work is actually to connect it to X-ray bursts. X-ray bursts are things observed in astronomical data here, U of M, and there are some peculiarities that are tough to explain. And our motivation for it came out of actually recent data from James Webb Telescope, where these little red dots and these kinds of objects that don't really have any agreed upon explanation for the cause of these, and in the context of galaxy formation and big black hole formation. So we hope to use our model to sort of explain some of these X-ray bursts where there's these sudden X-rays that come out of nowhere from these exotic objects, and we think our work can actually explain some of these effects that we see.